Hi, I'm Steven Pierre Ramsamy. My student ID is 1485927. I'm doing the BIT 353 Network Architecture and Protocol Assignment 2, and today is the 30th of May 2021. So this subject uh, has been taught by Dr. John Ranking, and I'm going to start part 2, which is to show that I can implement big data, Internet of Things, cloud in a virtual environment network for a business, and they demonstrate the use of big data, Internet of Things, and cloud operation in the network. So I'm going to start with the big data. Like here, for the big data, I already installed the Apache Hadoop. Like here, the folder Apache Hadoop. I stored all the daemon files. There's like here, this is the Apache Hadoop data node. This is a Apache Hadoop name node, Hadoop distribution, and data node, name node, distribution, and this is I think the yarn distribution. So which I also did here, the command prompt. I created several folder on the Hadoop distributed file system, which I'm going to show you. And so this is the URL with the port number 9870. So this is an overview of the Apache Hadoop, and we've configured storage capacity of um, 476 gigabyte, and these are the distributed file system use. These are just statistics here. Name node journal, DFS file storage. I've only there's one node in service, like one device in service. Going to show you. Um, this is a data node. This uses of each data node. This is the usage capacity of the data node in displayed in a histogram. This is the capacity being used. Here is the device. This is a node, and this is a HTTP address. Volume failures. So till now there's no volume failures. Um, so let me just browse through the system. Like here, I show you from the command prompt. I created the folder Steven. There was one like assignment here, assignment and network. So here all the on the Apache Hadoop, I created these folder, which you can also create directory. You can upload files. You can cut and paste documents here. So till date, I've managed to create an online storage using the Apache Hadoop, which have three different folders. Okay, now I'm going to move on. I'm going to move on to the um, Internet of Things, which I uh, created here, the contigi, which I created on the virtual Oracle VirtualBox. So the application is running here. I'm opening Kuja. Trying new simulation. Create one simulation. So the Kuja simulation is actually it's just a simulation showing you how devices are interacting with each other. So here the modes or devices, or it may be sensors, any kind of devices that are connected to the internet, watch wearable devices, sensors, refrigerators, washing machine, can be anything. So I'm going to show you. Let's say I put 5 devices. Yep. So this is the environment, all these 5 devices, or radio environment. So there's a, okay. Mm, so here are all the nodes. Um, see, these are the radio transmission from device 1 to 4 and vice versa. Within each other, they are communicating. These are IPv6 IPv6 address. Let's get a closer look from here. All the packets at the both output. This is the output being captured from all the devices sending data across. Like here, CC created a connection with the server with the port number 8775, and if this is another IP, this is a client IPv6 addresses. This one is a UDP client process because I initiated the package UDP that sync. So this is quite a simulation how Internet of Things work in an environment with port numbers and UDP packets with their MAC address also. So you can move it according to the coordinates. See how the figures are moving. So you can position your devices anywhere you want, but within the environment so that they can get connected with each other. So if one of the devices move far away, might not get the transmission, the signal. Like here, see this one, number one, is not being connected. So once you move it in the range where the signal frequency are being transmitted, so all of them get interconnected. So this one is that this part is done on Internet of Things. Now I'm going to show you um, for the own cloud services. So in a virtual environment, so I created my own cloud here. This is a UCS own cloud which I created, and here on my desktop I created a client software with the account. I already created an administrative account with the IP 0.20, and I share it with this folder, synchronizing virtual file with a local folder. This is a file here. So I can initially what I can do is, let's say I just copy this PowerPoint I put it in this sharing. Okay, let's get that working. So with the own cloud services, you can, it's flexible. You can just access the file anywhere you are. So I get to the virtual machine, virtual box. I got my Ubuntu here. So see, this is a PowerPoint, Microsoft PowerPoint. I can save it. I can save it on my computer. So even though if I can share the file. Mm, what I can do with the client is a sharing folder. So this is the activity here with the server activity. I created Microsoft PowerPoint just here 1 minute ago with using the administrator account. So this is the shared document here. Mm, okay, so I shared it here. Um, okay, I'll share the using the public link. I can even just copy the link. Yeah, can create more accounts if you want. So I access the own cloud on my Ubuntu with the IP address 192.168.0.20, and I even created a shared link here, and this is a new Microsoft PowerPoint. So this is the end of part 2. Now I'm going to move to part 3. This is the end of part 2. Part 2, uh, I showed how the big data Hadoop works, how I created the free folder, created free folder on the Hadoop, and how I started the daemon services, the Yarn services, the HDFS services, and I show you the Internet of Things with the modes, interconnected the modes using IPv6, and I send UDP packets. I show you in the virtual environment, in the frequency range and within their coordinates, how Internet of Things work together, how they interconnect the transmitting data across. So the last one I show you in the own cloud services, how I uploaded a PowerPoint document on the server. So I can in the across the virtual box, I access that PowerPoint. So the last one, demonstrate part 3. I'm just starting part 3. Demonstrate how you did any free labs. So go to labs. So lab 1, which is the Cisco UCS platform emulator. Um, so I'm going to access the Edu lab here. It's taking a while. It's connected. Okay. Um, this is the browser of the UCS control panel, which the UCS has already platform emulator has already been created, installed. So this is the launch ECS launch manager. So I don't know, I've been trying since long. I got a warning here, unable to fetch domain. I'm just trying to log in, but it's showing me an error. I'm unable to connect to the server. I don't know what's happening. For whatever reason, I can't connect. UCSP. Let me try another username. UCSP. Again, I can't connect to the. I'm just going to show you the UCSP control panel. This is the equipment. All the equipment here that are online with the chassis number, name, model, all the devices that are connected. This is the fabric extender, the chassis. So the blade server, the enclosure, all the detail about the hardware, and again can't I can't log in for I don't know what's happened to EduLab. I can't log in on the UCS showing me um error message. Yeah, unable to fetch domain. I'm going to move to the second lab. Create a UCS lab in the following video. I'm going to. This link has not been working so far. I don't know the link. I think the link broke. I couldn't create that lab. The YouTube link is broken, and I don't have any much information about lab 2. What to do? The YouTube link is broken even here. And this is lab 3 EMC Isilon 1FS 8.0.0.0 simulator. So to download simulator, go from here. Mm, Again, here's this link is not working. Let me try copy up this link and paste it. This link cannot be found. It's not working again. I can't download this one. Uh, this is only for tutorial, but I can't. Without the software, I can't provide the simulator. But I'm going to explain briefly what is all about the EMC Isilon. Um, so this is the EMC Isilon X series. This is a front panel. Which have a control panel with they can do the administration work here. This is a like a um, lock, and the blue light that are running on um, indicates that all the cluster inside are working just fine. It's without fault. So this is the front panel, how it's look. It can harbors like 12 hard disk drive inside. Yeah, and this is the back panel of the EMC Isilon. We got two power supply here, and there's two green button, one in for the input voltage and one for output. The last one is red or amber. I think it's amber. It's for a warning sign. And like you can see here, zoom in. This is a power button for the node. It's a backup power button for the node. This one is the node. The hardware itself need to be shut down before you start this process here. And this one is the serial interface for administration purposes. You can connect your console to. This is for display. This is a VGA display port, and these one all the gigabyte internet client for the clients. These are USB ports, and again you got two clients gigabyte internet interfaces. This is a InfiniBand port, which you can connect one node to to another one, and this one too is an internet port. So this storage device, it can store too many petabytes of data and can run really large chunks of data within its distributed file system, and also it it mm, random access memory can start from 60 GB to to a very powerful let's say 128 or much more. And the Assgn X series, it provides unstructured data environment, increases efficiency in within modular design. You can even scale deploy the nodes. You can add nodes within like 1 minute, or you can start using it within 10 minutes. So it's really scalable. You can add a node easily. So it has an extra performance with an optical solid state drive and system ECC memory. And the Assgn X series it provides a nice solution with lower cost, easy management. It's flexible and clustered storage infrastructure. So the transfer of data are very fast. It speed access to data for workloads like file shares, home directories. So like storage capacity are very large in size, up to several petabytes. So that's it for the free labs. Unfortunately, I couldn't complete the lab because links are not working here, and also for I could not access here. I couldn't log in to the UCS manager like I showed you before. So here I would like to summarize up the part 3, which I show you which is already installed here, the UCSP control panel. And lab 2 was not could not access the link on lab 2. The video link is broken. Don't have any instruction how to do the work. And for the lab 3, I couldn't download the Assgn simulator because this link is broken as well too. So I just did a brief explanation of the EMC Assgn X series here. So thank you, John, for your kind attention. I would like to end up my video here. Thank you.